In this video, we'll be taking a look at another GitOps tool for Kubernetes, this time covering the latest version of Flux CD. But firstly, what is GitOps? In modern infrastructure, we store our infrastructure as code. The code goes into a source control such as Git. When we make changes, we push our code changes to Git. Now in a traditional infrastructure, we have a CICD pipeline that pushes the changes by applying it to our infrastructure. In GitOps, things work a little different. Instead of pushing, GitOps uses a pull approach and pulls the changes from Git directly. For GitOps to work, we need GitOps software that monitors changes in Git and is able to update our infrastructure, in this case Kubernetes. Now this software is called Flux. Now Flux runs on our infrastructure, monitors Git and Helm repositories for any changes. And when changes happen, it applies this change to our cluster. Today we take a deep dive into Flux, the latest version. So without further ado, let's go. So if we take a look at my GitHub repo, I have a Kubernetes folder, and in there I have a Flux CD folder with a README. And this is the introduction to Flux. We will take a look at creating a Kubernetes cluster, install some tools, we'll install the Flux CLI, and we'll take it for a spin. So be sure to check out the link down below to the source code so you can follow along. Now the next thing we're going to do is create a lightweight Kubernetes cluster, and for this I'd like to use a utility called Kind. Now Kind is a utility that allows us to run lightweight Kubernetes clusters inside Docker containers that we can use for testing, and we can throw them away when we're done. So to create a Kubernetes cluster, it's really simple. All I do is say Kind create cluster, I give it a name, and for this demo I'm going to run Kubernetes 1.26. I copy paste this to the terminal, and that will create my lightweight Kubernetes cluster in a Docker container that I can use for testing. And once that is done, our Kubernetes cluster is ready to go. Now one thing I'd like to do is run a small Alpine Linux container that we can use to install all the tools we're going to be needing for this demo. And this helps keep everything contained and portable so that it works on your machine. So to do that, what I'm going to say is docker run -it. I mount this working directory, the whole repo, into a working folder so that we can work inside the container. I give it host networking, I want to run Alpine, and I give it a shell terminal. So I go ahead and run that, and if I do ls, you can see all our Git source code has been mounted into the container, so it's accessible. Then I'm going to go ahead and install some tools. I'm just going to install curl, and we'll use curl to download kubectl. So go ahead and run that, and now that curl is installed, I can go ahead and install kubectl. So I say curl, call the kubectl address, download the binary, give it chmod execution rights, and move it to user local bin. Go ahead and copy that, paste it to the terminal, and now you can see it is downloading and installing kubectl. Now once that is done, I can go ahead, clear the terminal, and I can say kubectl get nodes, and we have our cluster ready to go. Now before we install Flux, the first thing I'd like to do in every demo is first take a look at the documentation. And here, as with every guide, we start with the documentation, and we're going to start with the core concepts, which is a good place to start with Flux. So I've linked that in the guide, so you can go over to the core concepts, and this basically just talks about core things like what is GitOps, so the whole thing about storing infrastructure as code in Git and having your infrastructure sync with Git. So you're going to have a few things like sources. This is the source, so where the source of the infrastructure is stored, like a Git repository. You also have reconciliation. This is the process where the application running in the cluster or the infrastructure matches the desired state somewhere like a Git repository. So this is the process of making sure the infrastructure matches the source. And then they talk about customization. So if you're familiar with a tool called Customize, Flux supports Customize overlay. You can either store raw YAML in Git, or you can store Customize YAML. And then we talk about Bootstrap. This is very important because this is the process of installing Flux into the cluster, and Flux can also run pretty much in a GitOps manner. So we can install Flux in our cluster and have it sync with Git. So Flux will automatically push the YAML to the Git repo and declaratively manage itself in a GitOps fashion. So to understand the bootstrapping process, we're going to take a look at the Bootstrap documentation. Now this depends on where you want to store Flux. So there's multiple ways of bootstrapping Flux. You can take a look at the document here. We can bootstrap for just general Git, GitHub, GitLab, Bitbucket, AWS Code Commit, Azure DevOps, and Google Cloud Source. In this demo, I'm going to take a look at GitHub. Now to do this, you're going to need to give Flux access to the Git repo where it needs to store the code. So in this case, we're going to use a GitHub personal access token. You set this token, and then there's multiple ways to bootstrap. You can either use a personal account and set up the command for Flux to bootstrap using a personal account. You can use a GitHub organization or GitHub enterprise. Now in this demo, I'm just going to use a GitHub personal account. So I'm going to grab a personal access token, and then we'll go through this command. Now before we go ahead and do the bootstrapping, we first need to get the Flux CLI. So I've documented that right over here. We'll get that from the GitHub releases page. So that is where Flux is being maintained. So you can go ahead and find Flux on GitHub. They have a GitHub repo with all the documentation as well as the architecture and a very few helpful links. Now what we're going to do is go over to the releases page, and on the releases page we're going to take the latest release. If you scroll down, you'll find the binaries right here. So what I'm going to do is I'm going to download over here Flux 2.1.1. So I've created the commands here. I'm going to download it using curl directly from GitHub. I'm going to use tar to extract it. I'm going to move Flux CLI to user local bin and give it chmod execution permissions. So I go ahead, copy that, paste it to the terminal, and that will go ahead and download Flux and install it. And now that we have Flux installed, I can say flux -- help, and we can see Flux is now installed. Now once you have kubectl configured and pointing to a working cluster and you have the Flux CLI, you can do some pre-flight checks by running flux check -- pre, and this will basically check some prerequisites and make sure your cluster is compatible with Flux, and you can see that has passed. Now the bootstrap process is the process of installing Flux in our cluster, and it's very important to understand that we can bootstrap Flux over and over as many times as we want every time we need to make a change. Every time we make a change and we re-bootstrap, Flux will push that commit back to Git, so it'll keep the source of truth in Git. We can also change the Git repo directly and edit the YAML there. Flux will then reconcile and pull that YAML back and apply an update itself. Now before I bootstrap Flux, what I need to do is set a personal access token. And to do that, all I need to do is export a GitHub token environment variable. So you go ahead and set it like this and paste the content of your token here. And now that I have set a GitHub token, what I can do is bootstrap my Flux install. So I can run the Flux bootstrap command. And in our case, I'm going to bootstrap against GitHub. So you pass the type of bootstrap you want to do. I'm going to use token auth because I'm going to authenticate with a personal access token, my owner, which is the username of the GitHub repo that I want to use, and here is the repository. So I'm going to use this repo where all my source code is in as an example. And here is the very important part. This is the path. Now notice the path that I give it, where I tell Flux to bootstrap, and basically it's going to commit the YAML into this repo, into this path. So here I am saying -- path Kubernetes Flux CD, because that is where my Flux tutorial is. But notice that I've created a folder called repositories, and this is where I'm going to be storing multiple Git repos. So I can emulate a real world scenario of having multiple repositories in my infrastructure. So you can see, if we take a look at the left here, that I have my Flux folder repositories, and in here I have an infra repo. So this is where I can go ahead and create like a cluster folder and a dev cluster, and I can have multiple folders for my infrastructure. I can have a dev cluster, a prod cluster, and this is very important because the way you bootstrap Flux is you have to bootstrap it against a GitHub repo, and you have to make the decision whether you want a mono repo where you store all the YAML, including Flux and everything like ingress controllers, monitoring, as well as microservice apps. Or you can also bootstrap Flux against an infrastructure repo and then have the applications like your microservices live in their own repos. So there are multiple ways to structure this. So in the Flux documentation, they talk about ways to structure your repositories, and you can use a mono repo structure. This is probably the most common structure, and they show you what the structure looks like. So you can have a clusters folder where you basically bootstrap Flux again. So you can have a Flux for production and a Flux for staging. All the YAML will go in there automatically when you bootstrap, and then you can have a folder for apps. So all your microservice YAML for each of your applications installed on your clusters would go into here, and also for different environments. And then you can also have an infrastructure folder where basically you want to store things like Helm charts for your ingress controllers, your monitoring, your service meshes, and the operational stuff that is required to operate your Kubernetes cluster. Now let's take a look at our repository structure. So in my Kubernetes folder, I have a Flux CD folder, and in here I have a repositories folder which is going to emulate all our GitHub repos. Now pretend we have 3 repos. The important one is the infrastructure repo because that is where we're going to be bootstrapping Flux. If I open that, I have a clusters folder and I can bootstrap multiple clusters. So I'm going to run the bootstrap command against the dev cluster folder, which is going to store all the YAML in here. Now I'm going to show you an example of 2 microservices, one called example app 1 and the other one called example app 2. Now the difference is in example app 1, we're going to be storing the deployment YAML alongside the source code of the microservice. So this is one traditional way of doing it. And to do that, then I'll have an apps folder in the infrastructure repo that has some special YAML, which we'll go over in a second, which tells Flux how to deploy that example app 1. Now notice that the deployment YAML is not in the infra repo. So this is the first use case I will show you. The second use case is pretend we have example app 2. Example app 2 does not have any YAML in its Git repo. It only has the source code. Now this is important because now in the infrastructure repo, I have apps, and in the apps folder, notice that the deployment YAML lives in here. So these are 2 scenarios. One scenario is the deployment YAML living alongside the microservice, and the other one is the deployment YAML living within the infrastructure repository. Now this will make a lot more sense once you see it in action. So let's go ahead and run the bootstrap command. So I'm going to say Flux bootstrap, copy paste this command, paste it to the terminal, and that'll go ahead and bootstrap Flux. Now there's a couple of things that's going to happen here. Firstly, note that here I have branch set to this feature branch. This is the branch that I'm using in the demo. So you'll probably pick your main or master branch when you're doing this. Now if we take a look at the command, what it's done is gone and connected to GitHub. It cloned that branch I indicated. It generated all the manifests and installing it into the cluster. And it's basically now pushed those manifests and synced it to the GitHub repo. And it's waiting for the reconcile to happen. And now you can see all the components are up and running and ready to go. So now Flux has gone ahead and installed itself to the cluster and pushed it to Git. Now to prove to you that it has done that, what we can do is take a look at the command line here. I have done a git status. I am on that branch, and let me go ahead and pull the origin of that branch, and notice that there are some changes that we've just pulled. And if we go to our repo and we take a look at the repo latest commit, you can actually see that Flux has gone ahead and done a commit there, so we can see it there as well. Now to check the Flux in the cluster, there's a handy command called Flux check. So I can go ahead and run that, and that will run a check against our cluster, and notice that all checks have passed. So if we take a look now at the GitHub repo to see what Flux has done, we take a look at the left side here in our clusters folder in the infra repo. You can see that under the dev cluster, Flux has gone ahead and added this YAML. Now there are a few new objects that Flux adds to our cluster. If we take a look at the documentation, we take a look at the GitOps toolkit component section. If we scroll down, there are a couple of things like Git repository CRD, Helm repository CRD, bucket CRD, customization CRD. All these CRDs are new objects that Flux has created for us that we can go ahead and use. Now the 2 most important ones are Git repository and customization. If I go ahead and do kubectl in the Flux system namespace, get the Git repository, you can see that this gives us a new object which basically points to the GitHub repo that we're on. And this is exactly the Git repository that we've used to bootstrap Flux. So it's maintaining itself through its own CRD. And if I take a look at the customization, this tells Flux where to get the YAML out of the Git repository. So if I run that, we can take a look and see that it's applied the revision. So you can go ahead and get these objects and also describe them to troubleshoot. So now that we have Flux installed and we understand the bootstrapping process, and we understand the repository structure, I'm going to show you some quick, easy examples of how to get a GitOps pipeline set up. So in this example, I'm going to show you a use case where you have a developer that has some repo with some codes in there. And what they want to do is they want to basically make a change and push their code to a repo. Now this will kick off your CI pipeline. Now CI is outside the scope of Flux. Flux doesn't build your code. Flux only does CD. So the CI part can be done with something like Jenkins, or like a GitHub action pipeline or any other CI tool. And then what you're going to do is the CI pipeline will then commit a YAML change to the infrastructure repo that I showed you earlier. That is where our YAML would be living, and all it does is update the image tag or the changes to the YAML, and then Flux will automatically sync that from the infra. So if we take a look at our GitHub repo under Flux repositories, we're basically going to have this Git repo of example app 1 where the developer will maintain their source code in their application. And here I have basically a Python application just called example app 1. It just returns hello world and it's v1.0.0. I also have a Docker file here for that application where I just install Flask and run that small application. And I've got the example documented here so you can try it out as well. So we're going to change directory to the Kubernetes Flux repositories example 1 folder, basically where that Docker file lives. So we pretend that we are now the developer. So I'm going to go ahead to my terminal. I'm going to go ahead and paste that change directory. If I do ls, you can see we have a folder and we have a source folder. I can change directory into the source folder. If I do ls there, we have a Docker file and an app.py. And then I'm going to go ahead and build my app by saying docker build -t, and I'm just going to tag this app. Now notice that I'm tagging it with an incremented version. So I'm going to change it to 1.0.0.1. That's a version that I'm going to start with. I'm going to go ahead and copy that command. I'm going to paste it to my terminal and say docker build and build that Docker container. And now that I have built my application, because I am not going to push this image publicly, I'm just going to use my local kind cluster to test this out. I'm just going to go ahead and load that Docker image directly into the kind cluster so that it's available and it can be pulled. So I do that by saying kind load Docker image, and I'm going to load that image that I've just built. I go ahead and paste this to the terminal, and that'll load the image into my kind cluster. This is just so that I skip the part of CI because we don't have a CI server in this demo. So we pretend to be something like Jenkins that does a Docker build and a Docker push. Now, if we take a look at our deployment YAML files, I'm going to go ahead and look at this folder, which is in the Flux CD repositories folder, example app. If I open that and I look at deploy folder, you can see I have some basic Kubernetes deployment YAML. I have a service that exposed the app. I have a deployment with 2 pods, and I have a config.yaml. Now, if I open up the deployment, let's take a look at that. This is just a simple Kubernetes deployment with 2 replicas, and here we are running that image. So we're going to exactly run the image that we've just pushed. Now, I'm not going to apply this YAML directly to the cluster. I'm going to use Flux to set up a GitOps pipeline. Now, the way to set up the GitOps pipeline is we need to take a look at the infrastructure repo, and in there we have an apps folder, and in the apps folder we have all the apps listed. We're going to list a new app called example app 1, and in there we need to define 2 things. One is a Git repository, so we need to tell Flux where is the Git repo for example app 1. If we click that, we have a look at that. That is just a simple YAML file. Kind is Git repo, the name of the Git repo, the namespace you want this object to live in, the interval to poll it, the branch that it needs to care about, and here's the URL to that. Now, if we take a look at the left-hand side here, we also have a customization.yaml. Now, the customization.yaml is slightly different, but this one is just called kind customization, and this one is basically just describing where the YAML is. You can see here that it has a path that points to the YAML. So we're basically telling it that our YAML is in the Kubernetes folder, Flux CD repositories example app 1 in the deployment folder. So this YAML here would live in our infrastructure repo. So all the definitions of Flux would live in the infra repo, but the actual YAML for the deployment lives alongside, if we take a look at the left here, lives alongside the example app. So you have the source code there and the deployment YAML there. So that's how we instruct Flux basically to wire up this GitOps pipeline. So we tell it a Git repo and where the YAML is within the Git repo. So now to set up that GitOps pipeline, I have all the instructions here. We're going to change directory to the Kubernetes Flux CD folder, and then we need to apply those two CRDs that we just showed. We're going to say kubectl apply. I'm just going to do all this in the default namespace. I'm going to apply the Git repository first, go ahead and copy that, and I'm going to paste it to the terminal, and that will create the new Git repo. And then if we take a look at the next line, I'll do the same thing and apply the customization.yaml. I'm going to paste that. That'll apply the customization. Then I can go ahead and check our Flux resources by describing them. So I can describe the Git repository first, go ahead and paste that, and you can see here that it has succeeded. It has a new artifact that it detected. So the Git repo has been bootstrapped and all good. Now if I go back, I can also describe the customization. Go ahead and run that, and you can see that it also reconciled. So now there should be resources in our cluster deployed already, and we can go ahead and check that by running the kubectl get all command. So what I'm going to do is I'm just going to paste that to the terminal, kubectl get all, and you can see our application is now running. Our example app is there. There's a deployment, there's a service with 2 pods. So this is our GitOps pipeline running for our example app 1. Now to test our app, what I can do is I can simply port forward by saying kubectl port forward to example app, and I'd run the port forward, and if I open that, we can see we can access our app. Now notice that the version number is wrong because we've deployed v1.0.1. So let's go ahead and fix that, and I'll show you how to make a change in your code. Now the only thing that the developer needs to do to change the code and deploy it is make the code change, commit and push that to the Git repo. Let the CI systems such as Jenkins or GitHub Actions go ahead and build the code, create the Docker image, and then your CI system needs to make a small commit change to the YAML file, updating the image tag. So to update the app, what I'm going to do, if we take a look at the left hand side here, I've got the app.py. I'm going to go ahead and open that, and what I'll do is I'll go ahead and fix this. Let's make this version 2. Go ahead and save that, and then in the deployment.yaml, I'll have to edit that one as well. I'll have to update that image to image 2. So I'll go ahead and save that, and then I can go ahead and build that Docker image with the new tag. So I pretend to be the CI system. I'm also going to go ahead and load that new image into kind, and remember that I've manually updated our tag. Now I'll show you some ways you can do this automatically, but the CI system should normally update the tag for you after the build has succeeded and then push it back to Git. So basically if I do git status, I've made the change to the app.py, and the CI system makes the change to the deployment.yaml. If I go ahead and git push this to my branch, that will go ahead and push the code to Git. Now if I go ahead and port forward again, we can see that the changes have automatically been rolled out through the GitOps pipeline. So Flux has monitored our Git repo and reconciled the changes and rolled out new pods. So some of you might be wondering, how do you update the YAML file from your CI pipeline? Now they do have some documentations about the manifest updating. Now you can see here there's a disclaimer here stating that this documentation is under review because the CI portion is actually out of scope of Flux. But if we scroll down, we can take a look at some examples here that they've used. There's string substitution with sed, and if you take a look here, they basically give you like an example YAML, and if we scroll down, there's a script called update k8s.sh. So they give you this sort of example script on how to do it. If you're running like something like GitHub Actions, they have an example here, and this script content, if you take a look at it, is basically just a bunch of sed commands that does replacement in YAML, and it goes ahead and looks for the specific image inside of the deployment YAML and updates the tag to a new one, and then you can just commit this basically from the CI pipeline directly. So this is one way to automate this whole like image tag updating in the YAML file through the CI pipeline. And basically what the script will do is it'll go to the deployment YAML and just update the actual tag there to the commit hash. Now there's an alternative way to use Flux as well by using the image automation controller. Basically what this looks like is, imagine you have a developer that changes some code in the repo. They push the code to a CI pipeline. The CI pipeline, all that it does is do Docker build and Docker push. The image gets pushed to an image registry. This is something you would normally do in both scenarios. However, in this scenario, Flux can actually sync with the registry, and then what happens is, if it detects a new Docker image has been installed or been pushed, it goes ahead and pulls it down, syncs it into the Kubernetes cluster, and then automatically pushes the YAML back to the infra repo. So this is an alternative method if you don't want to use the CI method of actually having the CI system push the YAML. And to show you an example of that, we can just re-bootstrap Flux. And the reason we do that is because we want to enable some extra components. We need the image reflector controller as well as the image automation controller. So I'm going to basically just take this command and I'm going to go ahead and paste that to the terminal. That'll go ahead and update basically Flux in the cluster and as well as the GitHub repository. Now, to have Flux automatically scan a Docker image registry, if you have a private registry, you're going to need to go ahead and create a Docker registry type secret. So if we take a look at my example, that's a normal standard command of kubectl create secret, Docker registry, Docker Hub credential. I'm just going to call it that, and I'm just going to pass in a Docker Hub username, password, and email. And I'm going to basically just run this, paste it to the terminal, I'll fill it out, and then deploy that secret. So I've gone ahead and deployed that secret. And also just what I've done is done a git status and a git pull, and we can see that it has already made those changes back to our GitHub repo because I re-bootstrapped that Flux install earlier. So now I'll quickly show you the image scanning technique on example app 2. So if we take a look at our Git repo, I've got the Flux repository folder and I've got example app 2 over here, and over here I don't have any YAML inside of this Git repo, so I only have the source code. So this shows you a way of like storing the YAML in a separate repo. So here I have app.py and a Docker file, similar exact copy of the same application in app 1. So what I'm going to do is I'm going to pretend I'm a developer. I'm going to go ahead and build and push example app 2. So you can just change directory into that folder where the source code is and say docker build -t, and this one I'm just going to build example app 2, and look at the tag here. Just going to make this tag as version 1. I'm going to go ahead and build that container image, and then what I'm going to do is do docker push and just push that to the registry, just like your CI system would do. Now, just like example app 1, we have to tell Flux about our application. So take a look at our infra repo. Under apps, we got example deploy 2, and take a look, I've got my deployment YAML in here that defines the YAML for the app, but then more importantly I've got the GitHub repository as well as the customization.yaml, the two YAML files that we had a look at earlier. The Git repo is the exact same repo that we deployed before. It's similar, just a different name, and it's pointing to the same repo and the same branch name. And then if we take a look at the customization folder here, I'm going to take a look at that file. That one is the customized, tells Flux basically where the YAML is located, and this time it's in the infra repo under apps and under the app example app 2 deploy folder. So this is an example where the deployment YAML lives in the infrastructure repo. Now I'm going to go ahead and tell Flux about these YAML files by saying kubectl apply. I'm going to apply the Git repo. So I'm going to copy and I'm going to paste that to the terminal and apply that. And then I'm also going to apply the customization.yaml. Now that we have told Flux about where the YAML in the Git repo is, we should expect it to now have reconciled. So if we take a look at our cluster, say git deploy, notice we still see the app 1, and this is an issue. So what I can do is I can go ahead and describe the Git repository, and notice that authentication has failed. That is because it is requiring a secret to access this GitHub repo. So in this case, if you take a look at my Git repository that we just applied, notice that I have a secret ref down here. It actually requires a secret, so this shows you how to set up separate secrets for separate Git repos. So the describe command is it's useful to troubleshoot these things. Now, to go ahead and deploy that secret, just take a look at this command. Flux gives us a handy command called flux create secret git, and I'm just going to call this example app to GitHub, the URL to my Git repo, the username and the password, and the namespace. I'm just going to use the default namespace to deploy this stuff in. So I go ahead and copy paste that. I'll fill out the credentials and deploy it. And after we give it some time to retry, we can now see that our source controller is ready. And if I do kubectl get deploy, we can now see that we have example app 1 and example app 2. So it's gone ahead and reconciled with the GitHub repo and deployed into the cluster. Now this is just the general GitOps pipeline setup. Now what if I want to make changes and push new images to the registry? In this case, we'll need to deploy a few more resources. One is the image repository, which is basically our Docker hub. And then the other one is the image policy. That is the version tag and the policy that basically Flux needs to follow to rotate the image. And the other one is the image update automation. So if we take a look at our YAML on the left hand side here, we take a look at first the image repository, and that's basically just image repository tells Flux where the image repository is. So in this case, we're going to use this image which is on Docker Hub, and this is the secret it needs to use to negotiate with and authenticate with that repo. And then we have the image policy over here, and this is the policy that tells Flux when to make the image update. And you can see we just use a policy semver, so every minor image will cause an update, so you can change the policy however you like. And then the last one is the image update automation YAML, and this one is a little bit longer and more descriptive, and this basically tells Flux where to reconcile and push the YAML to. So we tell it to push it back to this Git repository that we've already created. This is the branch it needs to push back to, and you can see here this is the path it needs to maintain and update. Now the interesting part is if we take a look at our infra YAML, the deployment.yaml, there's some magic there that tells Flux where to update the tag. If we take a look at that file, here where the tag is, you can see we've now deployed 2.0.0.1, and here we've put a comment. This is basically the syntax that we need in our YAML to tell Flux how to find the tag to update. So all I need to do is update the cluster and apply those 3 YAML files. I'm going to go ahead and copy these lines and go ahead and paste them to our terminal, and that'll deploy all those objects. So now to change example app 2, what I'm going to do is I'm going to go to my source code, change it. I'm going to just bump up the version number to 2, go ahead and save that. And then what I'm going to do is I'm just going to say docker build and build it with that new tag. Go ahead and run that. That'll build up a new Docker image, and I'm going to go ahead and push that to our registry. So similar to how a developer would basically make a change, push to GitHub, and then the Git repo will run the CI pipeline which does docker build, docker push. And what I'm expecting here is that Flux will now pick up this change because the new image is in the registry. Now we can check and debug this if we take a look at this command that I've right here, kubectl describe image repository. If I take a look at that, if you run that, you can see successful scan, found 1 tags, no new tags found, next scan in 1 minute. So it's basically just going to poll the image registry, and you can use this describe command to troubleshoot. And if we wait some time and I have a look again, you can see now it's found the new tag. You can also describe the image policy. If you take a look at that, that is just kubectl describe image policy example app 2. And I did that, and you can see here that it has found the latest tag, updated from 1 to 2. You can also run kubectl describe command on the image automation, the image update automation resource. And if you do that, you can also see that Flux has committed and pushed this commit back to the branch. So it's gone ahead and updated our image tag. It used to end in 1, now it ends in 2. Now if we go to our GitHub repo and we go to this branch, we can actually see that Flux has made that change. If we take a look at that commit, we can see exactly what it's done. And here you can see it's gone ahead and bumped up the tag. So that is the image updater in a nutshell. So hopefully this video helped you understand GitOps with Flux CD. Now if you liked the video, be sure to hit the like button, subscribe, and hit the bell. And if you want to support the channel even further, be sure to check the Patreon link down below, or hit the join button to become a YouTube member. But as always, thanks for watching, and until next time, peace.